When you need to analyze data across multiple sources like DynamoDB, PostgreSQL, MySQL, and Snowflake, you typically face the challenge of either moving data to a central location or deploying and maintaining separate connector infrastructure. This approach requires operational overhead and can lead to data duplication. Athena managed connectors eliminate these challenges by handling connector deployment and management automatically. You can query 12 different data sources without managing connector resources in your account. You create connections directly in Athena without deploying any infrastructure. You can query across S3 and external sources in a single query without moving data. Athena registers federated catalogs in AWS Glue Data Catalog automatically, enabling unified data access. You can optionally configure access controls through lake formation for security governance across federated sources. Data integrity verification in S3 traditionally required additional tooling or was limited to fewer checksum options. You can now select from 10 checksum algorithms including MD5, X#3, X#64, X#128, and SHA-512. When you upload objects, you can provide a checksum value that S3 validates before storing, or S3 automatically applies CRC64 NFY if you do not specify one. You can request stored checksums during downloads to verify data integrity end-to-end. S3 replication preserves checksums when you replicate objects across buckets, and S3 inventory enables you to audit checksums across datasets. For objects uploaded without checksums or with different algorithms, you can use S3 batch operations to calculate checksums at scale without downloading data. These capabilities are available at no additional cost across 37 AWS regions through the AWS CLI and SDKs. Enterprises running interactive data and ML workloads in notebooks need to meet security and compliance requirements by keeping compute traffic within private network boundaries and accessing resources that are not publicly available. With VPC support for notebook kernels in SageMaker Unified Studio, you can execute notebook kernels within your configured VPC to isolate interactive compute traffic within VPC boundaries. You can connect to private databases and internal APIs directly from your notebooks without exposing them publicly. The notebook kernel inherits domain-level VPC settings and security groups, allowing administrators to manage network policies centrally rather than configuring each notebook individually. This keeps your SQL, Python, and natural language workloads isolated within your VPC while maintaining access to private data sources and internal systems. Managing network topology configuration for distributed training clusters is complex and requires manual updates when cluster composition changes. Without proper topology configuration, GPU to GPU communication is slower, NCCL collective operations are less efficient, and training throughput suffers. SageMaker HyperPod now addresses this by automatically selecting the optimal network topology configuration for your Slurm clusters based on GPU instance types. The system inspects instance types at cluster creation and identifies their networking characteristics to choose the best fit topology model. It adapts the topology dynamically as your cluster evolves through scaling operations and node replacements, maintaining optimization throughout the cluster lifecycle. HyperPod supports tree topology for instance types with hierarchical interconnects like ML.P5 instances, and block topology for instances with uniform high bandwidth connectivity like ML.P6E instances. For mixed instance type clusters, it selects a compatible topology across all nodes. The feature enables topology-aware scheduling by default, requiring no configuration on your part, so you can focus on your training workloads while the system handles topology management automatically. Organizations using AWS IAM Identity Center for authentication previously could not access serverless notebooks and data agent capabilities in SageMaker Unified Studio, forcing them to use separate IAM domains or switch between multiple tools for different workload types. This feature extends serverless notebook support to IDH domains. You can now access notebooks and IDHE domains where your teams already authenticate. You can combine SQL queries, Python code, and natural language prompts within a single workspace instead of switching between separate tools. The built-in data agent generates code and SQL statements from natural language prompts to accelerate your development workflow. The notebook environment scales from interactive queries to petabyte-scale processing through its integration with Amazon Athena for Apache Spark, enabling data engineers, analysts, and data scientists to handle analytics and machine learning workloads in one unified environment. When managing ACL-enabled knowledge bases, you face challenges troubleshooting document access issues and confirming that sensitive documents maintain proper restrictions without manually tracing permission inheritance across data sources. Amazon QuickSight now provides ACL verification that addresses these challenges. You can verify user access to specific documents instantly by navigating to the Sync Reports tab in your knowledge base. From there, you enter a user email in the permission checker to confirm their document permissions, receiving one of three results: access granted, access denied, or no ACL found. The feature also allows you to view all users and groups with document access in a single panel, giving you complete visibility into applied permissions across your ACL-enabled knowledge bases. Running HPC workloads requires quick recovery from node failures, real-time monitoring, and efficient log management. You can now automatically reschedule jobs affected by node issues at the highest priority using expedited requeue, reducing recovery time for your workloads. You can monitor jobs, nodes, and scheduling in real time through a Prometheus-compatible Open Metrics endpoint that integrates with your existing monitoring tools. You can send Slurm database daemon and REST API daemon logs to CloudWatch Logs, S3, or Data Firehose to diagnose accounting issues and debug API integrations. You can control scheduler audit logs independently as a dedicated log type, allowing you to manage ingestion and storage costs separately from other operational logs. Previously, modifying individual rows in Apache Iceberg tables from Amazon Redshift required moving data to external processing engines, which added complexity and latency to data pipelines. You can now perform row-level UPD, delete, and merge operations directly on Iceberg tables without external engines. You can execute these operations on both partitioned and unpartitioned Iceberg tables, including S3 tables, with support for multiple partition transforms such as identity, bucket, truncate, and time-based transforms. The merge command lets you combine insert and update logic in a single statement for patterns like change, data capture, and slowly changing dimensions. Tables modified by Redshift remain compatible with other Iceberg-compatible engines including Amazon EMR and Amazon Athena, preserving interoperability across your data lake. AWS lake formation permissions are supported for these write operations. This feature is available in all AWS regions where Amazon Redshift operates.